Welcome back, everyone. Today we're going to get into part 10 of the Introduction to Insect Taxonomy, and we're going to be talking about the Archaeognathes. Uh, if you are returning, good to see you again. If not, if this is your first time here, please like and subscribe. It helps me out quite a bit. Leave comments, or if you have any questions about any of the material, I will try to respond to your comments, hopefully within a day or two. Just depends on how often I check. But we'll now be getting into the individual orders of insects, so there's quite a bit to cover. Luckily, with the Archaeognathes, it's a very small order, it's a very primitive order, so they're fairly easy to learn. If you will remember, this is all of the orders of the insects that we went over last time, so let's zoom in here because there's a lot to look at. We've already talked about the Protura, the Collembola, and the Diplura, and the Diplura rather. These are the Entonatha. So these aren't true insects, but they're very, very closely related to insects. And everything under them are true insects. It is true class Insecta. So the Archaeognathes and Zygentoma used to be called Thysanura, and that's a term that you'll find quite a bit, but they have since been divided into two groups. And so today we're going to start on the Archaeognathes. These are the bristletails, the jumping bristletails. There's a couple different names for them. But they're a fairly small group. They're a very, very old group. They evolved about 420 million years ago. And they haven't changed a ton, although a lot of them have gone extinct. A lot of the ones that we see in the fossil record are not really identifiable to any of the extant species, but there's not that many species of them extant anymore, meaning that there's not that many species still alive. So if we get into a cladogram of these things, so sometimes they're called the Archaeognatha, and I guess the more historically accurate name, or the Microcoryphia, generally in nomenclature, which is the naming of groups, we try to use the oldest name. Whoever came up with the name for the group first is supposed to get priority. And that's just that's why a lot of these group names shift, is because there's been so many records. A lot of them are very old, and so when we discover new old records, if someone had already named this, we try to use the oldest name as the technically correct one. It turns out that Microcoryphia is 11 days older than Archaeognatha for when people were working on this way back when. So technically, we're supposed to call them Microcoryphia, but you'll see both of these names pretty interchangeably. So like I said, this is a very small group of insects. There are only two families in the group left alive, extant. So there are the Machilids and the minor telids. So the Machilids, this is only about 250 species worldwide, and the minor telids are 170 species worldwide-ish. And this is obviously always changing when we discover new things, but generally with these extremely primitive groups, a lot of the species that have existed have already gone extinct because they've been around for a very, very long time. So what do you need to know about these guys? So they will be found usually in pretty damp places or places with high humidity, because they are pretty bad at maintaining their what would you say, the water content of their bodies. I just noticed a spelling error here. This is Archeo. There's no E here. It should be AEO, Archaeognatha. So yeah, so some of these are very oddly spelled words. So both the Machilids and the minor telids will generally be associated with damp places because of this. So frequently this will be under leaf litter, or like along coastlines of rivers, lakes, and even the sea, although there are no aquatic species of this group. So they're very old. They all jump, which is kind of interesting, and they jump as a defensive mechanism against predation. They tend to be omnivorous. I don't know if I spelled that right. And mating occurs externally, so external mating. And what I mean by that is what males will do is they will create spermatophores, which is an external droplet or package of sperm. And then the female, they will put that on the ground or on silken threads, and then the female will take it up. So there is no internal mating. There's the exchange of sperm occurs outside of the body. And that is a fairly common characteristic for the really primitive insects and insectoid sorts of things. When we talk about the body shape, so this is what they look like. This is an Archaeognatha. They have very long antennae. They have very large compound eyes that touch, usually. Sometimes the eyes are absent because there are blind species. They will have 3 filaments at the end of the body. They will have, the one in the center is the central caudal filament. And the ones on the side are the cerci. A singular one is called a cersus, US. They tend to be scaly, like butterfly scales, all over the body, mixed in with sedal hairs. So you'll have both hairs and setae. A seta, if you haven't been through morphology, I do have morphology lectures on this channel, so if you're wondering what some of these structures are, you can go through the morphology situation. I think there's like 24 lectures on that so far, and I might add a few more. But setae come to a point, and scales are broad and flat. So these broad, flat scales are all over the body, just like butterfly wings, and then they also have various pointed hairs. These are sedal hairs all over the body. The legs tend to be shorter than the maxillary palps. These long structures at the front of the body are maxillary palps. They are appendages attached to the mouth. So this is a maxillary palp. P-A-L-P, palp. A-L-P. So these are maxillary palps, and they are used in part of the mating ritual between the males and the females. The males will drum on the females in order to stimulate mating activity. They also have what would you call these? They are abdominal styli, and they're not super obvious. But they're like right here, and they're kind of in front of each of the legs, and then they will occur. They're these little filaments that come off of the abdomen and the thorax, and these are called styli, S-T-Y-L-I, and they're just little filaments that come off the abdomens. This is kind of where appendages used to be in the most primitive arthropods, but they're no longer appendages in the insects. The other interesting thing about this particular group is that they have very, very strong thoracic curvature. It's not so much evidence in this picture, although you can still see some curvature here. But they are in most of them, they have a very, very strong thoracic curvature. They can kind of flatten out, but in their normal state, they have this strong curve. And they are slightly flattened laterally. So this is in contrast with the Zygontoma, which are flattened dorsoventrally. And by what I mean by that is, if it's flattened laterally, it's kind of flattened side to side like a taco, and if it's flattened dorsoventrally, it's flattened top to bottom like a pancake. And that helps them move around in their natural habitats. Frequently, you will find these are in like rocky crevices. And things like that, so they can get through cracks. And a lot of times they're called like the rock bristletails, things like that. So, that's the general body structure of these things. But we have these 2 different families, and there's not a ton of species in these families, but the Machilidae and the minor telids. How do you tell them apart? There's a number of abdominal structures that are not easy to see from photographs, but the easiest way to show the difference between them in photographs is by how hairy and scaly they are. So with the Machilids, they tend to have a lot more scales and hairs on the head, the base of the antennae, and the base of the maxillary palps, and a little bit on the prothorax. So, and somewhat on the legs as well. So if we zoom in on this guy, this is a machilid. If we zoom in, what I mean by seedy and scales, these fine pointed, let me change this to a different color so you can see this arrow a little better. These, are you gonna change? These fine hairs are seedy. They come to a point, they're thin, they look just like hair. These up here, though, are scales, and if you look at them, they look like butterfly scales. They are broad and flattened. So it'll have a narrow base, and it will get broad, and they layer on top of each other. The machilids have more scales, and they tend to have a lot of scales associated with the maxillae and the antennae, and then all over the head and the prothorax. Yeah. So if we go to a better zoomed in version of this, you can really see the scales on the prothorax, and really see that like the basal segments of the antennae are covered in scales and seedy. And if we look a little bit at the maxillary palps, if we go back, you can see more of this of these colorful scales on the base of the maxillary palps, and there will be some as well on the base of the legs. If you look at the minor telids, so this is a minor telid, and let's zoom in on this guy, you will see some scales, back here on the thorax, on the second and third thoracic segments. But if you look at the head, you'll see more seedy, and you don't really see them, and this isn't a great photo, but you don't really see them on the maxillary palps or the antennal, the base of the antennae. And if you look at this minor telid, and you can really see that these guys, like this guy is on wood, they're very well camouflaged for their environments. If they're on rock or on wood, they are, if you were just walking past, it would be really hard to see these. Not to mention they are pretty mobile and they can jump, and they're fairly small. So the whole group of Archaeognaths are pretty much all less than 1 inch long. Many of them are only a couple of millimeters long, like 5 or 6 millimeters. So they can be very, very small. What you'll notice frequently is that the eyes are touching in this guy, on these guys, but if you, when they're not blind. But so you can see the scales on the prothorax, but if you look at the base of the antennae, very few scales, if any at all. The base of the maxillary palps, very few scales. Base of the legs, very few scales. You'll still see those pointed seedy, but you won't see the presence of the scales. And that's the easiest way to tell them apart. If you flipped these guys over and you could see the ventral surface on the sternites, you would see that the minor telids have smaller sternal segments, but it's not so easy to tell. You could do a drawing of it or something, but it's not the easiest way to identify these. If you just slap this under a microscope, you would be able to see those scales pretty easily. And so that would be what I would go with. And that's it. That's all those are the only families of the Archaeognaths. This is a very, very small group. When we get into the more modern, the things that have evolved closer to the present day, like the bees and things like that, there are many, many families. But for the Archaeognaths, that's it. Next time, we will talk about the Zygentoma, which are the silverfish, and they look suspiciously similar to the Archaeognaths, which is why they used to be considered the same group. But they are flattened dorso-ventrally, so they're flattened like a pancake. And these are the ones that you would tend to find around your house as opposed to along coastlines and things like that. So we'll talk about that next time, and I'll see you then.